Hello everybody, welcome to the live stream today. Today we're going to cover pretty much if you received a new printer, maybe it showed up on your doorstep, you don't know how it got there, maybe you bought it, maybe you didn't, but the video today is what do you do next after you buy your first 3D printer? Or maybe if you're ordering a second one and you just want more knowledge on how to get better at it. In today's video, I'm going to try to cover things in two different ways. The first way is going to be more or less kind of high level, to kind of get rid of some, maybe if you're hesitant to get into 3D printing. And then later on, I'll talk a little bit more about the details or the why. For me, I learn better when I understand the why and not just at high level. So I'm gonna try to get through a lot of content today. We'll see, I might not get through all of it, which is fine. We can always just do another one after the fact. All right, and yeah, hello everybody in the chat. And sorry, my monitor's over here and the camera's over here, so I might be looking back and forth a little bit throughout, but I'll try to remember to keep my eye on the camera where it belongs. All right, so with that, I've got two printers we're going to kind of show you today on, and then a few other props. But first, let's get started with the Macs here, and we'll save the best for last, being the brand new 5 Ultra. All right, so when you receive your first printer, setting it up is relatively easy. I'm not gonna spend too much time on that one. But first, I do want to go over some terminology. I think terminology is really important to show. This is just your cover, of course. Now, very important, when you first get this cover, it's statically charged. So the resin is going to kind of stick to the sides or to the front. I've tried the anti-static sheets and stuff like that. They don't work. Getting resin on here seems to be pretty, just happens to everybody. So instead what I do is I just get some saran wrap and I'll wrap the inside. Make sure it's nice and stuck on there. The saran wrap stick-in stuff is really good. And then that way it's not gonna have an issue with sticking, or if it does, you can just clean it off really, really well. Because also for some reason resin doesn't come off these things. If you try to clean it after the fact, I feel like it just makes it worse. So, little tip there. Of course, your accessories, we'll wait on those for a second. The way that they pack these things, they always pack the build plate not installed on the printer, which is smart. It's always wrapped up in the foam. Make sure you take them out because you don't want to pull the foam out and have these things fall over the place and potentially on the printer and damage it. All right, so let's go over the. What do you mean?
That's where you're streaming from?
I'm streaming to Lychee Slicer. So terminology. First thing here we have the screw. There's two different types of screws that you're going to run into on printers. This lead screw right here, which is the most common, and a ball screw. I'll show you what that looks like just real quick. Right here. So the ball screw is a little bit more expensive. It's got these kind of, the ball bearings inside of it. They help prevent any movement that happens and you get less layer lines and better, everything's better. The one that this one has, the traditional lead screw, and this right here is called the anti-backlash nut. More on that in a little bit later. All right, moving on. The next thing we have here is the vat. The vat, of course, is where your resin goes. The bottom of the vat here, you've got the release film. There's different types of release film. If it's clear like this, it's called FEP or NFEP. Or there's FEP, which is an older version, but you don't run that anymore. If it's cloudy, it's ACF film, but you don't really have to know about that kind of stuff. This is the release film. And this is the vat. Like I said, we're kind of going through terminology right now, so I apologize if this is not new to you, but if someone else knew it might be helpful. You've got the front LCD here and the top LCD there. Now, if you're trying to do a check on your printer, on the front LCD, there's a check you can run, but you generally don't want to run a check from here if you're trying to make sure this LCD, the top LCD, is working properly. You start a print, and we'll get into that later as well. Inside of here is the light engine. I can't show that to you, but for this particular printer, this is I have to look up the stats on it. I actually don't have those right now on the resolution. So there's a difference between the resolution of the screen and the pixel size. The resolution of the screen doesn't really mean very much because you can have an 8K LCD on a really small screen or an 8K LCD on a really big screen. And of course, on a 8K on a big screen is going to have bigger pixels than 8K on a small screen. And we call that the UM, or the size of the pixel. That's the most important thing you want to look at as far as quality goes. So if you're looking at a printer, less attention on the LCD size, more attention on the pixel size. And generally these smaller printers have really small pixel sizes, so they're very accurate at the cost of just not being really, really large. This particular printer is, the Mars 4 Max. I actually haven't used it yet. I've been waiting to use it ever since I received it a while ago. Elegoo sent it to me for this video to kind of teach you guys how to 3D print. So I'm actually really excited to use it, but we'll get more to the other one later. I'm more excited about that one, to be honest. All right, I think that's it for the terminology. Oh yeah, the backlash nut. So the backlash nut on some printers is on the top, on other printers on the bottom. The reason why this is important is because getting to the next segment, which is how to maintain your printer. So once you've received it new, you probably don't have to maintain it, but if you start using it from the factory, it might be a little bit more dirty and might need maintenance a little earlier on. And then later on, you really don't have to maintain it very often unless you're using it a lot. So the backlash nut can get kind of dirty and it can make the screw really black. So you can clean the screw off, but if it keeps getting black, you'll have to remove the backlash nut and clean that out. And that's why I kind of pointed that out earlier, where the other types don't have that. Behind that is the rail. The rail, this is a mono rail, there's only one. Other printers will have two rail systems. Generally, if it's a really big, heavier printer, you're gonna have two rails, it's a little more stable. A smaller printer like this one, having one is more than adequate. All right, so kind of getting more into it. So what you're gonna do when you receive your first printer is obviously take off all the packing film. Take off the front one, take off the shipping one here. There's almost always one on the bottom, and there it is. Make sure you remove these always, or you're not gonna have a very good experience. So at this point, let's talk about do and do not. Some mistakes you might commonly run into with your 3D printer. A do not is set this thing down onto a dirty surface and then put it back on your LCD, especially if it's resin or something like that, because the second you put this back on your LCD, it's dirty and you could ruin it. Some of these LCDs, some of the newer printers come with a screen protector on it, but if it doesn't have a screen protector, you're kind of out of luck. So make sure that both the LCD and the bottom of the release film are cleaned before you reinstall it, because you're gonna be taking this thing on and off, depending on your workflow, somewhat often. So just something really important to think about. The next thing you'll do is you'll add resin. Adding resin right now here in this might not be the best idea. So I'll just kind of, you add resin to the printer, and then you put your build plate on. But for that, we've got to turn it on. And to turn it on, we need power. So your power brick. And we're gonna need a power source. Luckily, I've got plenty. I think it was in the box, the actual cord. All right, real quick, let me pull up the chat just to make sure. Yeah, so right there, I love to keep the film on the front panel. I actually have a trick for that. Keeping the film on the front panel is helpful. Your fingers get really dirty with resin, and as you're touching the screen, well, with gloves on, as you're touching the screen right here, if you get resin on it, most of them, there's not a good protection film on this one. So what I do is I'll actually get a spare piece of the release film. And this stuff's pretty cheap. You can usually buy rolls of it, and I'll have links for where to buy it. I'll go over some accessories and I'll have links there. I will get a spare piece of the film and cut it, and then I'll tape it around here. If it's something like this one, I'll cut the release film just about the same size as this one, so it sits on it, and then when I tape it, it's nice and seated on there. And if any resin gets down, it won't go inside the LCD, behind the LCD, and this stuff, it's designed to not interact with resin, so it always cleans off really, really well. Another thing that I like to do is actually put a piece of painter's tape right here, and that way well, I'll show you a bit later, but when you remove the build plate, if you drip resin down the front, which seems to happen all the time, it'll land on the tape and not get underneath the vat, Because if it gets underneath the vat, it can get on the bottom of the FEP. If it gets on the bottom of the FEP, it can get on the LCD. If it gets on the LCD, bad things happen. One of the bad things, I'll put this back on. Sorry, this makes like an echo for the audio, so I don't want to have it off. One of the reasons why it's so important to not have this dirty isn't just because the hair or dirt or resin is going to destroy any accuracy you had, but when this printer moves up and it pulls the model away from the release film also has to pull away from the LCD. So if you can imagine, let me grab a piece of paper here. If this was the release film, it's going to be coming up as well, away from the LCD. It's gonna, bend, kind of like how this is bending, and pull away from the LCD. If your LCD is sticky, that release film can't get away from it. Or if you've got a bunch of stuff around it, air can't get underneath there. Some printers even have a system that will pump air underneath it while it's lifting up to assist with that release. But if it's sticky at all, you just now dramatically increase the amount of force it's gonna take to rip that model off of the release film. But if you just keep it clean, you never have to worry about any of that stuff. That's maybe a little bit more advanced. Let's get this printer turned on. Sorry, a little bit of a tangent there on what to do and what not to do. Yeah, strictly clean zone outside the printer. I'm the same way. Well, I'll show you a little bit. Let me raise this build plate. Let's go into the systems. There's always a way up here to tell this thing to go up to the top. Manual mode, there we go. Depending on the printer, they might have a 50 millimeters. This one goes up to 10 millimeters. And we're gonna go up. Let's keep hitting it, should go up. So I'll show you a little trick that I like to do. One of those do's and do nots again. So we're gonna pretend for a second that I've ran a 3D print. So I've got my build plate on. This build plate is a ball joint one, maybe a little bit older design now from Elegoo. On smaller printers, it does pretty good. On the larger printers, not a huge fan. The ball joint meaning there's a ball in there. So let's just say I'm done with the 3D print and I didn't forget, don't forget to put these screws in. You'll do it once and never again, because it'll make a mess. So let's say I'm done with my print and I want to remove the build plate. There's a couple ways you can do it. For one, the higher this is at the end, the easier it is to do this particular move. And this particular move is when you take it off, tilt it down like that. So you can imagine if it's low, it's really hard to get that lip there. And if it's taller, let's go all the way up to the top. If it's a little bit taller, it's easier to do that move. And that's a great way to not get resin. Even if this thing's covered in resin and it's dripping, if you just kind of take it off like this, it's gonna drip down, and I'll kind of hold it like this for a little bit, maybe tilt it, and it's all gonna drip down inside the vat. I'm not gonna make a mess. At which point I'll pull it out like that, and then I can go take it to where I'm gonna go process and clean it. So that's the move that I like to do. Even with a really tall print, it's generally gonna work out just fine to eliminate how much resin could potentially pour down the front of your printer. Of course, that little drip seems to happen. That's why I put a little piece of tape there. When I'm done, I always come back over with a little piece of paper towel and a little IPA, and I just kind of wipe it down when I'm done, just to make sure the printer stays really, really clean. There's a lot of pictures on the internet with, I don't think they got the memo that the resin goes in the vat and not outside of the vat, but the resin goes inside there, not out there. And on that, let's show you a little thing that I like to run to kind of help out with that. It's kind of one of those things that make resin printing a little bit easier. So when I first got started, I bought these little mats. And I put them in front of my printer like this. This was kind of nice and it worked out really well, and it's good for space. And where I 3D print, I have 12 3D printers, but it may be surprise you that I have very little room and I'm very tight for space. I'm working on fixing that, but right now I might have less space than most people. And so these little mats were really good, but even this, I actually don't have this much space in my printers. So I'd have to put them on it, and I only end up with this little strip right here. And it's okay, but it's a good, cheap solution. What I ended up doing, which was also a cheap solution, was I got these dog mats like this. These are big enough I can actually put a large printer right on it, or 2 printers side by side. And now I still have this whole area and these nice lips. They're relatively cheap, and this is one of those things that just make your life a lot easier. If you spill resin or spill anything, it's not gonna get out. I've also played around with the different mats. This one, if you spray it with IPA and you hit it with paper towel, it doesn't really grab or grip the paper towel. It cleans off really, really easy. This one's extra dirty because I use it for painting, but yeah. All right, so let's see, I got my little things here so I don't forget my talking points, but let me go through the chats real quick. Yeah, the sound and audio is a little out of sync. Sorry about that. We're trying to fix that one. I think what we're gonna do is later on, we'll re-edit the video and put it back up with the stuff in sync. So I'm sorry for now, it might be kind of annoying, but something about the way OBS is handling the video was throwing them out of sync. I just reading the chats real quick. It's also nearly impossible to clean cured resin off of the screen. It is near impossible. So if you end up putting resin on here and it gets cured, I've seen a lot of tricks where people try them. I've advised different people I've worked with to try all the tricks on the internet that I've seen. I've never seen one that like really, really works. It always leaves a little bit of a residue or even some stickiness afterwards. Honestly, if you get a bunch of resin on your screen, it's probably time to replace the screen protector or replace the screen. Okay, everything else is just about the drips. All right, so moving on. Do's and don'ts. This is, especially if you're brand new and this is your first time resin printing or just getting into it, this should be helpful. Don'ts. Don't rely on this to keep your area safe. It won't. You are going to have to position your printer in a space where you can vent and you're not getting outside light, not even reflected outside light, as it can cure resin. You can have the cover on it that helps, but when you take the cover off to work with it, any resin on the top of the build plate can start to cure, and it's just a pain to clean off. So it's better just to have your printer in an area where you can ventilate it outside and you're not getting any ambient UV light. And yeah, don't rely on these things for safety. Same thing with these masks. They provide them. I'm not really sure why. This is more of a spit mask. Like if you sneeze, you don't get spit on somebody. They're not meant to prevent anything from coming in. They're really not going to do anything for you. So the do's is, I've got 2 options to show you. The slightly cheaper option, this is just a respirator, and the filters on here are, they're organic, or they've got active carbon in them to absorb the toxics that come through. Now, when your printer's printing, if you got it in a room with ventilation, it's gonna be fine. It's not gonna get in your house. It's not gonna do anything bad. This is for when you're cleaning the chemicals we're using, and while the resin is post-curing, so post-curing means after you remove it, you have to wash it and then you cure it again just to harden the resin that might be left over from the wash and to really cure it all the way through. You're releasing, that's where a lot of the chemicals are coming from, more or less from the actual cleaning solutions, especially as the cleaning solutions get resin absorbed into them, they start to really come out. That's where this is important. This is the cheaper solution. The more expensive that I've started using lately that I actually really enjoy is this. It might seem like overkill, but I actually find it's just as easy to put on and take off as this one, and actually a little bit more comfortable. And I can be deploying, I have less, every once in a while with this one, I'll still get a little smell of like IPA, and I'm like, oh, it's not really, it's working, but it's not working as well as it did. Once I got this one, I'm not getting any of that anymore, and I also have to worry about splashes in my eyes. I've had a few splashes that get close, never anything in my eyes, but it's been close enough where it's like, ooh, that would have been bad. And I'll have a link for this one as well. It's not that much more expensive, but I found the overall experience to actually be pretty pleasant. I just put on my gloves before I put it on, so I'm not worried about smearing it. I take my gloves off and throw them away before I take it off. And that way I don't have to worry about getting it all dirty. All right, more into the do's and don'ts. If you come with this plastic spatula here, what you don't want to do is use it to Well, I guess first on that one, if you have a failed print, which means you try to print something and it didn't happen, and there's going to be hard bits stuck inside of here and you have to get them out. What you don't want to do is use your finger, even gloved or not, to pick them out, or use something sharp to pick them out. There's another option that's called a vat clean. And what that is you essentially take an object. You can take an old support off of an old model. If you have those, you can use a piece of paper, or there's little vat clean options. And we'll provide the links for those later. You can print those out, and what you do is you put them into the corner just below the build plate. So you imagine where the build plate is, so you want it to be about right here in the build plate. So about right there. You're gonna make sure it's gonna get the LCD, which is below it. The LCD is smaller than the vat, which is why you wanna use this as your guide. You're gonna put it just there in the corner and apply light pressure. On the front of the LCD, there's gonna be what they call an exposure test or self-cleaning. They call it different things, but let's see if we can find it. Exposure right there. So we'll turn it on. Oh, that one's doing so that one did the whole logo. We don't want to do the logo. Tank clean at the bottom, there we go. What this does, it exposes the entirety of the LCD with UV light. I'm gonna turn it off because I don't have my glasses on. And that's going to cure a sheet of resin. If you've got your little thing there in the corner, when you cure that sheet of resin, it's gonna stick to it. And when you lift it out, better if this isn't on it. When you lift it out, it's gonna take everything out of it and your printer is gonna be clean and ready to go for the next one. But if you use a scraper like this or your finger to try to dig that sheet out, it most likely is going to damage the FEP, scratch it, put a hole into it, which that could, one little hole in your release film all over it, that could be a new LCD replacement, or at best a new replacement for the screen protector, and just a lot of work to clean it up. You don't want to do that just because you didn't want to do it the right way. On that note though, where to go? I thought I grabbed it. Welcome to live streams. Somewhere I have my silicone spatula. Oh, there it is, underneath there. Do mix your resin in the vat. You do not have to empty it out all the time. So we want to make this as easy as possible. And right now I know I'm making it maybe seem a little bit difficult, but really the high level is put resin in, tell print to start, come back, remove print, and you're good to go again. When you come back to do that process I just said, if you don't want to take all the work to dump out the resin back in the bottle, it's a big waste of time, and you just want to keep it there and for storage, you just want to mix it before you do the next print. The reason why you want to mix it is because over time, all the coloring or whatever's in the resin will kind of settle to the heavier elements will settle to the bottom. It'll separate like a glass of orange juice. You just want to mix it back in before that first print. And the reason why you want to squeegee the release film is because the pigmentation likes to really collect to the release film. And when you start a print, the very first layer, only the very first layer that's printed actually makes contact with the build plate. And if that first layer has a bunch of pigmentation in it, it's not going to hold as well. So going through and mixing it, not only mixes back in your orange juice, but it takes that pigmentation off and puts it back in. So a little something like this that's soft, when you squeegee it, it's going to mix it in really well, and it's not going to damage the release film. Unless when you're mixing it, you're beating eggs and you're hitting it like that. That might damage it. So when you're doing it, just do it nice and soft a few times and you're good to go. That's all you have to do. You can leave the resin in there for months, like truly months. I've actually tested that. Mix it up and you can go back and you can print with it. As long as it's not exposed to UV light, it's going to be fine. Resin will last about a year after opened, so that's probably about how long you can leave it in there. Just mix it up and print again. It's pretty easy stuff to do. All right. Kind of towards the end of this is on the do's and don'ts, is they give you a scraper that's relatively sharp. Now I've seen more than a few people cut themselves, because what they might do is that first layer is bonded on here really, really well. Let's take this off. There we go. that first layer is bonded on this really, really well, and it's hard to get off. So they'll sit there and kind of chisel it, and maybe they'll do something, but they'll slip and they'll get like a finger or something like that. There's a couple mistakes on that one. One, you can adjust these so that those are easy to come off. Regardless of what resin you're using or printer, those can be adjusted, and we'll talk about that later. The next thing is these things are sharp. They're a little dangerous, but they'll also, not only they potentially gouge into your finger or into your desk or your silicone mat, but they'll damage your build plate. So instead, there's a little thing like this one that's it's not sharp at all. It's completely unsharp. But I found this thing to get in there actually better than something sharp and won't damage anything and won't cut you. It's not sharp at all, but it works really, really well. If you don't want to spend that extra money, it's fine for these things, but what the biggest don't on that one is not necessarily not using this. The biggest don't is not taking the time to adjust your settings so that the prints come off really easy, so you're not chiseling them off. Again, we'll get into that later. All right, let me look at the chats real quick. What brand is the small one? The small what? The respirator. They're off brands. I found off brands that are high quality. Just because, actually no, the small one is 3M. Sorry. This is 3M, but these are off brand. I looked at some test sheets and stuff like that, data sheets, and of course I was looking for options that were cheap to encourage people to buy them, to actually use them versus nothing. And again, I'll have the links for these, but these are all relatively inexpensive. I didn't want to force someone to go buy like a $60 or $80 thing. In fact, everything together is cheaper than you might think. All right. Yeah, just bend the yellow spatula. I agree. I don't use either of these. I have a lot of them, but I just toss them. I don't know what this could be good for. Like I've tried to use it to peel these off. It doesn't even work better than this thing does. So I found it not to be very useful there either. I've tried to find a use for it, but so far I've failed. If you guys have any ways you have found a use for it, I haven't. Oh, thank you. It says thank you. Yes. It says I've always managed to be super helpful for even someone who's been printing for years. Thank you. I try to get into the. I try to stay high level, and you notice I may suck at that. But if I do go deep, I try to do it in a way where it's easy to explain and understand, and it's not so deep and crazy that I lose you or myself. All right, we're almost done with this one. Gloves. These ones are okay, but what I've noticed is that these thin ones, especially when you're cleaning your parts, the cleaning solution with the resin can sometimes penetrate these and get into your skin. Over time, and I don't want to scare anyone on this one, safety is really big, but it's really, really easy to overcome. And once you overcome it, you're safe. You're good to go. So don't let safety be a concern to get into resin printing. A little ventilation. Slightly thicker gloves is what I'm about to get into. A respirator, and that's pretty much it. Like you're safe. Everything else beyond that is extra, and you're welcome to go extra, but you've covered the needs. And so you can double these up if that's what you have to be extra safe. But when you run out and it's time to buy more, I would just get ones that are a little bit thicker. I think these ones are 0.5 or these ones are 0.6. I would probably recommend looking for a 0.5 or 0.4. These ones are a little bit thick. But they're also the nitrile. Get the nitrile, get them a little thicker. You never have to worry about it again. You're good to go. You're done. All right. Yes, you can knock the plate out of level. Okay, so let's talk about that for a second. We've gone to the safety. I did want to cover safety before we went into terminology, before we went a little bit further into things. So let's go, well, we'll talk about this one, they'll bring the other printer up real quick. I'm sure we all want to see the other printer. This ball joint can get out of level. So what that means is if I'm over here, and let's say this is on here really tight, I'm holding it by this thing, and I'm smashing it down like this to get the prints off, there's a very, very good chance that it's going to go out of level. Now, here's a terminology thing for you. We use the term level, but it's not really level. This printer being level doesn't actually matter. I've done some tests where I've actually propped mine up, and the only thing that happened is my build plate was cleaner when it was done, because it was tilted by a little bit and it was able to drain a little bit, but it didn't cause any issues at all. As long as it was level enough that I didn't run out of resin in here, it was an issue. We say the term level because it's easy and it's convenient, but really what we're doing is we're making the surface of the LCD match the surface of the build plate. And that's what we want to do. We want those two surfaces to be as flat as possible. The more flat they are, the higher chance of success we're going to have across the board. And I'll get into more on that later as well. But just these ball joints, the reason why I said I don't like them earlier is because they come out of level a little bit easier than some of the other ones that have a 4-point system with a little more better built, in my opinion. But like I said, also on these smaller printers, it's not that big of an issue. It's mostly on the really larger issue where there's a lot of force over here, a lot of leverage, where it can move that around. All right, let's put this guy down. And for the rest, let's get into the other printer. All right. Oh, this one's fun. I haven't actually opened this yet either. I was kind of saving it for this hole for you guys. And let's get to it. Same thing on the hood. I like to keep this hood clean, so I'm gonna put a little plastic on it before I use it. The tools are gonna be the same thing we just saw. Well, let's see, I'm pretty sure. The power brick, antenna. Oh, this is wireless, we got the antenna. Filters for filtering your resin. If you put your resin, if you do remove your resin from the vat and put it back into a bottle, you do want to filter it. That part is very important. And it's the same thing, but with a USB with some stuff on it. They usually always come with a little toolkit as well, so you can kind of tighten everything. This one did as well. This one even came with some extra, the other one came with some extra bolts for the ball joint. I've almost never used those, by the way. Like these extra stuff in here, you'll use these bigger wrenches to unlevel and level it, and I'll show you that later. But for the most part, I've never had to replace a screw ever in all the prints I've done in printers. So it's nice that they include it, but you shouldn't have to stress about that. Just as before I talked about, the build plate is packed in the foam, so be careful to remove it manually. All right. And this guy is very different than the other printers. So let's talk about these. This is new, and I think we're gonna see more of this printer in the future. So it's good to talk about it. First thing, we'll notice some similarities. You've got the same screws to hold down the vat. The vat looks the same. It has the same shipping film on it. So just make sure you remove those. Ugh. There's a shipping film on the LCD as well. Put it back on. This is like all you have to do when you buy a brand new printer. It's really this easy. Put the screws back on. See if there's one under there. There is. The newer printers have this really cool texture on them that makes it easier to, I don't know if it necessarily makes it easier to remove, but it makes it so that they hold on a little bit better, so you don't have to bake your resin as long to make it stick. I haven't talked about that yet, so I won't get into too much until we get to that section. But yeah, they're pretty helpful. Also, this won't scratch that. I mean, it kind of can, but it's really hard. This has a lever instead, which is really nice, instead of that screw. Okay, but you'll notice some similarities. Build plate, screw, rail, vat, the lighting engine, front LCD, top LCD. They're basically the same. The biggest difference between the two is that the other printer, after every single layer, this entire arm goes up and down, and when it goes up, it pulls that film away from the LCD in like a bubble fashion. In this one instead, this guy goes up and down. And so it actually peels it off like this, instead of like this. That is going to dramatically decrease the force that is required to remove the print from the release film, as well as the release film from the LCD, because there's a lot of open around there. I haven't seen any numbers published on how much it is. I would like to get a rig where I can actually measure that myself on these printers to see, where it really ends up and how big of a difference it makes. But even if it doesn't make a huge difference, they are a lot faster, because this thing can move up and down at a faster rate than lifting up because of the way it releases. The whole mechanisms between everything can just move a little bit quicker. All right, go back to chats real quick. The Mars 5 Ultra. You've lost the VAT screw before. That would suck if you lost these little ones right here. I used to order yours today. Yeah, we'll go through this, and if you have any questions about it or anything you want to see a closer look of, just let me know. Saturn 4 Ultra, same. I have a Saturn 4 Ultra as well. They are very similar to this one. This is basically a Saturn 4 that's shrunken down. I do want to know if there's going to be some leveling with this one. With the Saturn 4 Ultra, at the time of making this video, I want to say I believe it's a small percentage of users are having a really hard time with print sticking to it. Hopefully it can be resolved with just some firmware updates. They might have to release a new build plate, but this thing is so much smaller, it may not have that issue at all. Yeah, how long can resin sit in the vat? A year, honestly, if you just mix it. Yeah, so any word on when Lychee will support the Wi-Fi capabilities of the Saturn 4 Ultra or the Mars 5 Ultra? It's coming. I don't have an ETA now. It's rather complex to build it out. Unfortunately, it's not quite the same system as the Saturn 3 Ultra used. So we kind of have to start from scratch. It can be rather difficult to build it. So the development team has been working hard on it. They're still working on it. But as of now, Lychee does support this printer, so you can add it in. But there is a big difference, and I'll get into that later, about this printer and the other printers on how you work with them. But I think for now, we're kind of running out of time. Let's move on. So at this point, we've pretty much covered, you've got your printer, you set it up, you add your resin. Now what? Well, you've turned it on, but yeah, now what? So let's go over here and I'll show you some things I got prepared for you. Let's talk about what a slicer is first. That's probably important. What is a slicer? So if you're new to 3D printing, you've got 3D objects that exist in the world, but they're basically just 3D objects. They're all digital, they don't really mean anything. What a slicer does is it takes a 3D object and it cuts it into a bunch of flat pictures. But it also includes the code that goes along with the pictures. That's called the G code. So that's their primary function, is to take a 3D image and make a bunch of 2D slices out of it. Once that's done, you can turn a 2D image into a 3D model. And for this particular one, let me show you. That's, well, I guess that one's in the other room, but basically, you know, it's how you go from a 2D model to a 3D model, something like that. You know, where you can slice it into a bunch of little images and stack it up, and that's how these things print. They just print with a bunch of images stacked up. All right, but the slicer does a little bit more than that as well. So also what they do is they give you some extra features to defeat physics. So the issue we have right now with physics is that, wait, this one. When you're trying to take something that's a 3D model and make it in the real world, physics now apply that don't exist in 3D space. And the physics we have to overcome is weight, pill force, and suction force. Now there's a terminology there I want to talk about, and that's the difference between pill force and suction force. They get swapped around a lot, I see. So pill force is the layer, like that picture I showed you earlier of the paper. If you get to something like, let's say like a neck, it's a much smaller section versus like the whole head. So this is gonna, if I'm printing just that smaller section, it's gonna have a lot less pill force to remove from the fat versus a larger section. That's pill force. Suction force is, let's say I took a cup and I put it down inside of a bowl of water and I tried to lift it up. That cup is a suction cup and it's not gonna wanna come out. The amount of force to remove that cup is really, really high. Many times greater than trying to release the cup if there is no suction force, which is the difference between suction and pill force. So that's one of the things we have to deal with. The slicer helps us overcome. The next thing, of course, is the weight. This is a physical object that has weight. And you can't just print things in mid-air. They have to have something to print off of. So overcoming all of these issues is really, all the tools in the slicer are really designed around these very simple concepts. I'll show you what those kind of look like. So I'm here to the slicer. This is the calibration part. This will be the first models you print, but first let's just hide those and bring in a really simple object. And that is a square. We'll scale the square up. So scaling can be used, you know, to decrease weight or size. See, that's one of the physics things that we have to deal with. But also rotation. This right here, if I were to, here, let's actually do this, a better example. If I were to try to print this like this, my cross section, which looks like this in the slicer, is relatively small. But if I were to rotate it like that, my cross section is now really, really big. The pill force is going to be up by quite a bit. But let's say I didn't want to use that much resin. That's very heavy and very expensive. I wanted to defeat the weight problem or the resin problem, because cost. Resin's the most expensive thing, not your printer, not your cleaning supplies, your resin. So anything we can do to save resin, as far as high success or not using where you don't need to, that's where we're going to save you the most money. And one way of doing that is on hollowing. So if I hollow this model out, it's now hollow on the inside. Now what we have here is a suction. So we have little tools like suction detector that let us know, hey, we've got suction cups here. Suction cups are bad. So again, they're all just tools to make it easier, and the slicers are full of lots of tools to make this easier. Another one, as I told you, we can't print in mid-air. We're in the real world now and physics matter. So let's show you what that might look like. Let's take this little chicken, move it up. I've got this little thing called island detectors. Now, if you're new to 3D printing, some of this stuff doesn't really matter that much. You can get models that are ready to go, and that's the easy way to do it, is just to get them ready to go and then use the slicer to just make all the images, stack them up, and then send them to the printer. But very quickly, you might want to print some of your own stuff, because that's where it gets really fun, in my opinion. There's a little tool called Island Detector, and that's going to search the whole model real quick for any islands. An island is just, it's something, this in thin air, this is an island. If I wanted to print this, I would have to have something that connects, let's say my table, to it, because things can't float. They need something connected to them to the floor, or in this case, the ceiling being the build plate. Let's clean up my desk while that's running. All right, so what we have here are islands. All these little dots right here is an island that has to have a support or can't print. You'll even see there's like some of them look bigger. And here we've got different support types, like a medium's a little bit bigger than a light, so we can come in here and just make sure these islands are supported. It doesn't take much to hold the weight of an object. Once the weight's supported, most part will print. You'd want more than this, but as you can see, some of these tools are just to overcome the same thing. I'm not going to get into it too much on this video. I want to stay more on topic of like how to get started, how to get going. But that's just kind of important to realize that all of the extra features and tools in Lychee, they're just to make your job easier to overcome physics. Real quick, I'm gonna check the chat real quick. Yeah, any suggestions to get the print off the build plate? I'll go over that in just a second. I'm gonna have to start moving a little quicker. I'm gonna run out of time before I get to that section. What is the area filtering? I didn't see that. What is area? Oh, area filtering on the yes. What is area filtering on the island detector? This is a new feature in Lychee Slicer, and I might have to run it again. Oh no, right here. So what this is gonna do is it's gonna say, only show me the biggest islands. So not all islands need to be supported. If you're getting, this is a little bit more advanced, getting into it, but if you're gonna start getting into your own supporting of your models, know that not all models, not all islands have to be supported. If they're really, really small, it's better to let them flatten. They're not gonna stick to the release film, they're not gonna ruin your printer. They're gonna get picked up by the layers above it, and it's just gonna be a very small area that's a little bit flat, but most of them are so small you will literally never see it. So what this does right here is I can say, well, only show me islands that are bigger than 0.1 millimeter cubed. So there's only 4 islands on that one. But if I go smaller or bigger, let's say 0.2, I might get to the point where there's less and less and less, so 2. And of course, if I go down to 0, no filtering, 22 islands, minus the ones I've already supported. So that's what that does. Very, very helpful. So you can actually, let's say the bigger islands, a bigger support, smaller islands, a smaller support, islands under a certain size, you don't care about. So that just helps you filter and makes it a lot easier. Like I said, all these tools, there's a lot of tools in Lychee that might be confusing at first. They're just to overcome basic physics, suction force, pill force, weight. That's pretty much it. Oh, and with hollowing, the way you go over this one real quick. I don't want to miss this one. When it comes to hollowing, having a suction force is bad, but Lychee gives you the tools to get over it. Let's do a quick suction cup detector on this guy. He's got a big suction cup right there. I wouldn't want to print this way, by the way. Anything that's facing down towards the build plate is going to not look very good. Anything that's facing up is going to look really, really good. So what I probably would do is delete these supports. Let's rotate this model. Let's do rotation on the plate. So that surface is now going to be onto the plate. Let's lift it up. Let's go back and go back to hollowing, run another suction cup detector. Since I changed the orientation, suction cups are going to be different. And there we go. So now all I do is I go to hole. Let's apply a hole here at the very bottom. And what that's going to do, make sure I go all the way into the model. There's a little view here so I can see inside of it. I'm doing this really fast, so I'm not getting the best job on these. If the holes are red, it means that it will still 3D print. But if you export it, if you try to like take this from something you're just gonna slice and print, and you wanna export it as another 3D file, those holes won't be exported. However, if you slice it, it will work just fine. Let's run another suction cup detector. And you'll see we're good to go. Because now there's a way for the air and resin to get inside the model. Suction cup avoided. All right, let's move on from that. And let's go to, all right, so you've got your 3D printer set up. You've got your 3D printer set up. So what do you do next? Well, you now know what a slicer is, and you have to download the slicer, and you can just get that from lycheeslicer.com downloads, and we'll have the links in the description. Once you have Lychee Slicer, you need to print your first prints. Now your first print on the USB, they're gonna give you like a Rook or something like that one. That's not a calibration print, that's just there for fun. If you wanna print it, have at it, but that doesn't tell you anything, and it's not there to tell you anything. It's there to make you feel good, which is fine. But what we really want is to calibrate the printer. Like I talked about earlier, we want the printer to come off this really easy, but we also want our prints to look really, really good. And so that's where calibration comes into play. The first thing we need to calibrate, and the first thing we're gonna get into, is the, hide that. Let's see, I'm missing one, there it is. Seems like I got 2 centers, that's all right. The first thing we may wanna print is these build plate calibration parts. And the way that they're designed is you'll notice there's 5 of them in like dice. What they're gonna do is they're gonna confirm that this build plate is level on all 4 points and in the center. These are gonna help you make sure that you're square to the LCD. If you're not, there's ways to adjust it. It's also gonna make sure that layer 1 is starting at the right height. Layer 1 can start where it's pushing down really hard into the release film. This can damage the release film and cause other issues. So we want it to be starting at the right height. These will tell you how to do that. Once this is done and your build plate is level and the Z height is correct, then you can get into the next part, which is resin settings. We'll get into that. This is probably the more complex part about this. So first thing, we need to add this printer. I do not have this printer in Lychee Slicer, so let's get it added. We're gonna add a 3D printer. We're gonna click on add here. We're gonna do resin. I'm just gonna type in Mars. If I want you to narrow it down, I can type in Mars 5. So there we go, there's the Mars 5 Ultra. Now that printer is added in Lychee Slicer. So now we need to configure the resin. There's different resins you can buy and all different stuff. So we need to know what resin you want. Now, you can either add a new resin or you can use an existing one. For me, I've got a printer that's pretty close, which is the Sonic Mini. And so I'm gonna take this one and I'm gonna go over here, click edit and make a copy. And when I copy it, I'm going to copy it over to, whoops, I did the wrong one thing there. I meant to copy it to the printer. I'm gonna change it so it's copied onto my Saturn V Ultra. So now I've got a copy over here on my Saturn V Ultra, right here. Or you can add new resin and start from scratch either. I'm just doing this to be a little quicker right now. Once you've got your resin added, right here, you have to adjust the settings. Let's talk about these settings for a second. The first one settings are the burn-in layer settings. This is set to only print 4 of these. The burn-in layer is the bottom layers. The first, in this case, 4 layers to be printed. So the first 4 layers will have an exposure time of 22 seconds. So that UV light will be on for 22 seconds. That's quite a while. It's gonna really burn that in, and that's what's gonna make it stick to the build plate. Transition layers. That means we're gonna slowly transition from 33 seconds down to the normal layers, which are only doing 1.8 seconds per layer. So instead of just going from 22 seconds directly to 1.8, we're gonna slowly transition down over 3, so it's just not quite so harsh. This is gonna help us prevent a few types of failures. The next part here is a little bit more confusing. This is lift distance. Now you notice there's 2 numbers, left and right number. What this means is it's called TSMC, or it's just multiple stages. So the first number is when the thing first starts to lift. Let's see. So when this guy, let's, hold on, make this a little bit better for you. All right, so the first stage is, when this thing is closest to the LCD, this is my LCD, we're gonna pretend here for a second. When it's really close and it's pulling up, this is when the model is really attached to that release film. And so if I move up really fast, there's a good chance it's going to rip apart, especially if you consider these things are printed at very, very thin layers, 0.05, or I like to print at 0.03 millimeters. So if I pull it really quick, you can rip that to shreds, especially once you get a model that's in there with all the supports. It can be pretty jarring. So what we do is we start really, really slow at the beginning. Put that release film under tension. In some cases, it'll release in the first few millimeters, nice and gentle. Then we want a little insurance, because maybe most of our layers, because they're small cross sections, release in that first little bit. But we've got a really big section later on that is on there a little bit harder and needs a little bit more space. So that's the point of the second layer there in the TSMC, that second value. We'll lift slow and then lift fast for insurance. So that overall lift height is, about 6 millimeters for normal layers and 8 millimeters for bottom layers. But what goes up must come back down. So retraction is the opposite. The number on the left, this number right here on the retraction, this number right here on the traction is where we begin. That's at the top. We can go down pretty quick. We don't want to go down too quick because we're still lowering into a vat full of resin. And resin can be very thick. So if we got a model like a mini with a guy with a sword and we're pushing that, that arm through resin, especially if that arm is only a few layers, like this is only a few layers, so it's really, really paper thin. We don't want to push that through resin so fast that it kind of breaks it. That's where we get layer lines and failures and stuff. So we're going to go through, back up a little bit. You can start slow, but for that last one, you can actually go really fast. There's really no speed limit on that one. So if you want to get speed, slow, really fast. Going back down, there's a speed limit here because of that force of pushing through resin. When you get really, really low, now we start to get to a new issue of the PSI against the LCD. This is why we'll slow down again as we get right to the very bottom. So basically, as the build plate is closest to the LCD, whether you're lifting or retracting, you're going to go slow. But as you get further away, you can go faster. And that's the entire concept around these two values. This first value is the top, the bottom value is the bottom, or the right value is the bottom. And that's why they're fast and slow. Now, wait time before print. What this says is once this thing gets all the way to the bottom and it's is basically resting on the LCD, how long will we wait before we start curing the resin? The reason why we wait at all is because when the motor stops spinning on these things, let's put this in frame here, sorry. When the motor stops spinning on this thing, this thing isn't done moving. There's flex and bend, they're gonna move a little bit, and that resin's still flowing. When that resin stops flowing, we can cure it and get a really, really high accuracy. So much accuracy, in fact, it's going to change the way you calibrate, which we'll get into in a little bit. That's the rest time before wait. Now, you'll notice that rest time before wait is listed both in burn-in layers and normal layers. If you're using a ChiChuBox motherboard, these settings, it always actually uses the normal layer. If you're using .goo, which may be a little bit more advanced in this video, it will take into both values. But just know if it's CTB, it only takes in the normal layers and not the bottom layer. So these numbers right here are actually more placeholders than anything. Light intensity, we won't talk about that. So normal layers are the exact same, everything I just talked about. The difference is these take place for the remainder of your entire print versus only the first 5 layers. The one thing is layer thickness. So we looked at that piece of paper being sliced up. The layer thickness is the thickness of each slice. The lower that number, the more layers to be sliced up. And so the longer your print will take, but the higher quality it will be. Also, you can imagine if I've got a really thin layer of cake, I don't have to leave it in the oven as long as a really thick layer of cake. So thin layers generally don't need as much UV exposure time as thick layers. But how do you determine what that exposure time is? That's the next part. So let's go back to here. Let me close out this resin profile. That's all you need to know about the resin profile. Everything else, don't worry about it. And we've got our printer added. We've got our resin profile. So now, and let's say we've already printed our calibration prints. Early in the conversation, it was asked, how can I calibrate my bottom layers so that everything comes off easy? I kind of already told you the answer, maybe secretly. If you make sure that the layer thickness is correct and your build plate is level, and if you're using light off delay, you won't have to use that much burn-in time. You may go under 20 seconds for something small like a calibration print like I showed you or I'm about to show you. For something slightly larger like a mini, you may need around into the 20 through 27 seconds depending on the resin and the layer height. And for something really big like terrain or a big model, you may have to go up into the 30 seconds. But that's generally about it. You might see some users where they're using like 50 seconds or more, or they're using 10 burn-in layers and 10 transition layers. Normally, that's generally, in order to get the stuff to stick, that's generally because the leveling or the Z offset is not right, and they're overcompensating for another issue. And if you just simply solve those problems from the very beginning, you never run into them, and all those weird, crazy things you might see or issues people are having, you never run into them, so you don't care about them. All right, let's go here and show in this guy. Just get rid of those ones. I'm just gonna delete all these guys because I don't need them all here. Looks like I made a copy of those. All right, let's zoom in here. So how do you determine what is the correct UV exposure time for all the rest of the layers? There's lots of calibration prints. Of course, I'm gonna talk about this one because it's my own design, and I get to, so the way this works is this is a very unique calibration print in its own. There's nothing else like it out there, not just by the design, but how it actually works. What this does, it's a true tensile strength calibration. So the way you work, is you'll notice these little pillars right here. You don't pay attention to those pillars, they don't exist until these boxes fit. The fit should be snug, but not tight. If you're forcing them in, it's too tight. If you put them in and they're loose, it's too loose. I had a little assistant, I was gonna have him help me where he could determine if it felt loose or tight to kind of show you that even if you're not experienced with it, you'll know when it's too tight or loose. And if it's a little bit too loose or a little bit too tight, you'll be surprised that you may only be off by 0.05 millimeters if you were to take some digital calipers and measure it. It's gonna be very sensitive to very small amounts of changes in the size. Now, the reason why these work is because the longer resin is exposed, two things happen. One, it grows, physically grows, and you'll actually consume more resin. The second thing is it becomes harder, which is a good thing to an extent. And so if you just simply lower your UV exposure a lot until things are accurate, you may have lowered it so much that it's not strong anymore. And so using other things like the light off delay we explained about, or the lift speeds or lift distance we already talked about, those things will actually make your resin grow. Adjusting those properly will make your resin physically shrink. If your resin physically shrinks, you can add more UV exposure time to make it physically grow again. This is how, and remember that UV exposure time does two things. It makes it grow and it makes it harder or stronger. So being able to add more UV exposure time to maintain dimensional accuracy is the point of this calibration part. So, and that's why, first thing, make the boxes fit. Now you know you're dimensionally accurate. Now you look at the pins. At dimensionally accurate, not only do you know these pins are the correct size. Just simply exposing them until they all print wouldn't work because it's going to bloom and a 0.1 millimeter pin might actually be larger than that. So the entire test would be invalid. So once the boxes fit, you look here, the more pins, the more strength you have. That's good. If you have no pins, that generally means that you've got something else wrong with your printer. Maybe your LCD is dirty and there's too much pill force. Or maybe you're not using enough light off delay for your resin. Or maybe your resin's too cold. You want to print between, if you can get up to 24 degrees Celsius, do, but really stay above 20 degrees Celsius. Above 30 degrees Celsius is getting a little bit hot. It'll still work, but you want to stay, let's say 24 to 28 degrees Celsius is the sweet spot for pretty much any resin I've tried. So if you've got 8 or more pillars and the boxes fit, you are now calibrated to resin tensile strength. If now, not all resins can do that though. So if you end up getting to a point where adding more light off delay or changing your settings isn't doing anything and your printer's in good running order, that's generally a really good indication of the resin isn't designed to be tensile strength. Maybe it's a flexible resin or something like that. And that's fine. Understand that that's a thing as well. If you print with some specialty resins, they're going to behave slightly different, but that's kind of also the point of the test. You can actually test different resins to find the one you like with this calibration, not simply just find a calibration that's going to give you a really high success rate. All right, but that should be your first print. And the way that works is now that I've got my model, it's here on the build plate, I've added my printer, I've added my resin. All I have to do is click on export. Now from here, you don't want to use anti-aliasing. We're not going to get what anti-aliasing is on this one, but basically from here, we get to change the format. Well, this format is right now we're only setting to use .goo. So the advantage of .goo is what I talked about earlier, where right now, this will, this wait before print will actually take into account. But there's one more big thing that some people might have noticed. The Mars 5 Ultra doesn't lift or retract. It has a VAT system. So the Mars, this one is one of the easiest printers you'll use because all this goes to 0. It doesn't matter. You end up with only changing a few settings. Transition layer count, exposure time, how many layers, how thick and how many layers, and your light off delay, which is the wait before print. That's it. On this printer, that's all you're setting. On a different printer, let's say like the Max, everything I just explained applies, but not on this one. That's also true on the Saturn IV Ultra as well. So now we export the files. I just do it to my desktop. What you never want to do is slice directly to the USB. That's going to cause problems for you. Slice to the desktop. Once we have the Wi-Fi printing in, you can slice it and it'll send over Wi-Fi. But at this point, you're just going to slice it directly to the desktop or wherever's convenient for you. Copy it to the USB. Once you have the USB, which I set down on the ground, there we go. So we'll pretend that I copied this on. You put it into the printer. Make sure the printer's turned on. Let's see here. This also should lock into place. Yeah, I could move it forward, now I can't. Now let's go through and we're gonna print USB file. And I don't have the boxes on here, the one I just sliced because I didn't put it there. But essentially it would be right here, you'd hit go, we'll do the rook, and hit print. At which point, you're done. I know there's a lot of information in there, but you could maybe understand how quick it can be where, you know, that assembly was very fast. Add resin, go into the printer, load up the calibration print, add the printer, add the resin, you know, grab that profile in the way I just described it to you, slice, and now you're done. At that point, you've printed a file. Let's turn this off. Once it's done, where I talked about how to remove it, how to remove the print from the build plate. At that point, the only thing we didn't really talk about is how to clean or failures. We're a little bit over time, but let's go into that real quick. Failures, that's very important because you might run into failures and it's good to know what to do if you see them. All right, so there's a version of my guide, if you don't know, on the Lychee Slicer's website. And from here, it's all broken down into everything I've talked about here and more is all here, all of it. But if we go down here to troubleshooting print failures, we're gonna see the kind that we're gonna see the most, which is maybe nothing on the build plate. So we just ran a print, there's nothing on it, it looks like this, that's not a good thing. So what we wanna do on that one is this will tell you exactly what's wrong. Maybe our temperatures are too low, or you know, maybe we're not level like I talked about, or maybe we do need to increase the exposure time a little bit more because we're using a resin that just needs more. Not all resins are the same. This one right here, half the build plates are stuck. That one maybe need a, where half of them are missing. A little hard to see over here. Let's see if I can pop that out. There we go. Half of them are missing. We're not level. Those build plate calibration prints I talked about earlier, that makes sure this won't happen. Things can still fall out of level, especially that ball joint I talked about earlier. This is an indication that it may be time to go print those build plate calibration. Make sure it's out of level. Oh, by the way those things work is you actually measure them with digital calipers. They should measure 1 millimeter. If you don't have digital calipers, 10 stacks of paper is about the same. This is a big one I see more often. Where the rafts, you get the support stop printing halfway through, or they don't start printing entirely. This is an issue with Z offset. Again, build plate calibration solves these issues. It's all listed here in the guide as well. So most everything, oh, this is most important, just the supports. So you print this, the supports printed just fine, but the models didn't. Do you need to increase exposure time? Well, the answer is no, your supports printed beautifully. Maybe you calibrated off of accuracy instead of tensile strength. So maybe you do need to adjust your settings like I talked about earlier to obtain more strength. But there was enough strength here to print the supports. So most likely the issue is the support tips are probably a little bit too small. You know, remember we talked about overcoming physics here. That's an issue with weight and peel force. Probably not suction cups on minis, but the weight and peel force is definitely an issue. This is all listed here. You know, come here to check it out. And you know, if it's just important, if you have a failure, identify the type of failure, identify the solution. I see far too many new users going back to the calibration settings, increasing exposure time, changing stuff. They have no faith in the way they calibrated, and they're just running around in circles, wasting a lot of time, and probably getting very frustrated. But everything I talked about earlier, all the way down from keeping your FEP clean, your LCD clean, calibrating, you may never run into those issues the entire ownership of your 3D printer, especially using the squeegee to mix the resin and check for any hard bits, running the vat clean. Your printer may last longer than anyone else's. I've got my first printer, it's 3 years old, maybe $5,000 worth of resin. It still has the original FEP. The original FEP, not even the original LCD. I did have to replace the LCD, but that was because of a voltage bug from Anycubic, which they fixed it and patched it, that's no longer an issue. But original FEP on that thing. And I've never had a resin leak, so far. But all right, let's go back to questions and see if anyone else has anything else. Because I think for the most part, that's mostly it. Yeah, most of the questions were, what are the tilt speeds, stuff like that. Maybe you saw I zeroed all those out, so maybe I should have made that a little bit more clear. at the beginning, but yeah, you just zero those out. On the printers themselves, there's a fast and slow speed of the tilt. Play around with which one you like better, speed versus accuracy. It's your call. Can you print an object flat on the build plate? Ooh, for Resin 3D printing flat on the build plate has a lot of major issues. The one being the Z offset. These aren't the most accurate square printers on the planet. Even after doing your best to print build plate calibration parts, you're going to be off by 0.2 millimeters on average, even with doing a good job at leveling. Getting them perfect is pretty difficult, if not impossible. The LCD itself can kind of bow in the center, or they are warped in the center. Same with the build plate, they're generally slightly warped in the center. They try to do their best, but you know, these aren't $5,000, $10,000 machines. They're a couple $100 machines. So printing flat on the build plate, you're gonna have issues with just the fact that they're not very square. The other issues you're gonna have is you want to avoid printing something flat. Anything flat parallel to the build plate like this is bad. You always wanna tilt it. The reason for that being is, you know, like I talked about, that resin initially is very, very thin. And if you're trying to lift it off that FEP in thin layers, it will shred unless there's something, you know, bigger behind it to hold it. And generally, if you print on something like this, you know, you can build up that thickness over time, slowly, starting with a small point like this versus something flat. It's just not going to work very well. And so printing flat on the build plate, you don't get to angle it. Next thing is that it's called stepping. Stepping, let's go to this one, maybe it's up. Trying to see where it is in here. If I've got it here, I think it's normal layer calibration, where I have a good picture. There we go. So if you're printing at 50 you're going to have more slices, thicker slices than 30. So if you can imagine, if this was printed flat on the build plate, all this stepping you're going to see. Anti-aliasing can help to an extent, but it's not going to completely solve your problem. That stepping. By tilting a hard surface object, so something that's round, it doesn't matter which way you tilt it, it's going to be the same. But something with more of a straight edge on it, if you tilt it more, the stepping is going to be reduced. And so printing flat on the build plate doesn't let you tilt to avoid some stepping issues. I see some people talking about this super special angle. That special angle to reduce stepping only works if you're printing a cube. Most things we're printing have multiple angles on them, so trying to find like the perfect angle for one messes up the others. So instead, don't look for perfect angles, just look for like Y shapes and V shapes. So things like print like trees or like buildings. Let's go back. Reading the comments again real quick. I think that's it for now. I know we've gone over on the video. We started a little bit late, so it's okay to go over just a tiny bit. If there's no other questions, let me just make sure my notes, make sure I didn't forget to cover something. Nope, I think I got everything. I think, yeah, I think we're good. I guess one of a quick thing for maintenance, they're really easy to maintain. Generally use like a super lube, kind of a silicone grease. I've talked to the manufacturers of these rails. They even say sewing machine oil works on the rails, and then a grease on the main screw. They're really easy to maintain. You don't have to do much. If you keep them clean, they'll run forever. What are my preferred anti-alias settings? Good question. Let's do that real quick. Maybe get a little bit more advanced, but I'll show you that real quick. That's in my guide, actually. Let's go back here. I think it's even, I got everything in here, post-processing. Yeah, we want to talk about cleaning as well. I'll get to that in a second. Let's just go up here to the search. So my favorite anti-alias settings look like this. So it's going to be 2 pixels, HD anti-aliasing on, anti-aliasing on supports off, with 2 pixels and 0% gray offset. This is going to be, you're not going to notice a reduction in quality. You really aren't. It is going to do quite a bit. Here, let me actually do this real quick. It might even show you a better example. There's 2 versions of my guide out. There's the one on the Lychee Slicer Discord and then the one on the Google Doc. The Google Doc one I update a little bit more frequently, but I always try to go and update the one on Lychee Slicer as well. Let's see here. I recently posted a new picture for the anti-aliasing though. There you go. So it's maybe hard to see on the stream, but there's an example of on or off on what those settings can do. I can post a link for the full, really large, like 50K picture of that in the description as well when we repost this video. So if you want to see it, you can look there and really see what anti-aliasing can do and how it doesn't really do anything to your details. What it does do, however, it's really hard on your computer to slice it. So if you're slicing for like a 12K or 14K LCD and your computer's not what I would call like a gaming computer, it may be a little difficult for you, these settings. So just keep that in mind. Let's get here to the we haven't talked about post-processing yet. What happens when you remove the printer? Of course, first thing, scrape it off. What I do is I take a spray bottle and I spray them off first. I've changed, these are older pictures, but I do a first wash in really dirty IPA. I never ever clean. I then do a second wash in cleaner IPA. And then generally from that point, I'm doing a few extra washes after that. And then you dry them. I use a heat gun, a low powered heat gun, to dry them off. Now you can let them sit for a while, but make sure they are completely dry. If you talk to any resin engineer, they'll say let them dry for a day before you post cure. Using the heat gun, I can generally dry within, less than a minute. I don't use the heat gun on high settings. It's on a medium setting because if you heat up the resin too much, it'll kind of warp or bend, actually become very rubbery-like. So heat it up enough just to get it nice and dry, let it sit for a little bit, and then throw it into the UV cure station. I cure for about 2 minutes per side. Most things only have 2 sides, so that's between 4 and 6 minutes. Cure time is enough for most resins, but look at the resin manufacturer settings. Some resins need a long time, like 30 minutes. Mostly for specialty resins though, that most new users won't be running into. And I think that's pretty much it for that one. Here's an example of a wash and cure station. There's lots of them out there. None of them are terrible. Just do some research, find out which ones you like. Of course, I have some suggestions here in my guide. I've even developed my own wash buckets. I have their links in there as well if you want to check those out. They're kind of fun. All right, let me just check back up on the chat. Yeah, hollowing solves on resin, reduces pill force and everything like that. Yes, hollowing is the best thing you can do. It reduces the weight, saves resin. Like I said, resin's the most expensive thing, not your printer, it's resin. So that 3D hollowing you get from Lychee Slicer Pro, the suction cup detector, it's gonna save you a lot more money than it's gonna cost you. Plus, it reduces failure. Weight and cross-section increases failure chance. It also makes it so you have to use more supports. Supports leave damage. I don't care how good you are. Supports will always leave damage. You can put them in really good spots and make them small, and be super professional at it and get less damage, but you can never get no damage. Hollowing allows you to get away with a lot less support than a full-size model does. Hollow everything, most everything. Minis don't need to be hollowed, but anything larger than a mini, try it and see if it works. All right, if there's nothing else today, I am going to call it quits, and I'll let the chat just have maybe a few more seconds to see if anyone else wants to chime in. Yeah, so you do, okay, supports inside the model. Not as many as the outside. Mostly what you want to do is do an island search and look for any islands. And for what I do on those ones, let's show you real quick. This will be fun. That's a good question, thank you. Let's pull up Lychee again real quick. Just bring back in this guy. We're gonna turn on hollowing 3D. All right, actually let's make it really big so it's easier to deal with. We're just gonna scale him. Whoa, 200%. There we go. Now we'll apply hollowing. Let's delete these boxes. There we go. Okay, so we've got this interior here that on this one it doesn't need to be supported, but on other models it would. So what I do here is you can either go to exterior, so you're looking at the inside. Now my hollowing, my supports for the inside are pillars. If you look at them, there's no break-off point. They're actually the same size on the inside on the tips as they are on the support shaft. The reason that they're pillars is because I don't want them breaking off. I want them to actually stay inside the model and stay strong. If they break off, I have a rattle, it's hard to get them out. Leave them in there, they can be structural. Plus I don't care what kind of damage they leave because it's on the interior of the model. But mostly what I'm doing is I'm looking in the inside. I'm looking for islands, I'm supporting the islands, I'm looking for big, really big overhangs. These aren't big enough. And I'm putting just a support here and there on the overhangs. You don't need much, but you do need something. And for the most part, that's really all you need for the interior. There is, on 2D hollowing, there is a very different system for putting in like a mesh system. That's really good if you're printing molds or engineering parts. I would recommend using that, or a big base. You want to have some internal structure. But for normal organic shapes, you want to use 3D hollowing and you don't need many supports. I will say though, I would recommend getting, this is a UV light camera or a flashlight. It's kind of big, that's a little bit expensive. You don't have to have one like this one. But if I shine this inside of a hollowing hole, it cures the inside really, really fast. Also when you're curing your hollowed parts, putting them in resin and having the resin, or putting them in your cleaning solution, and having the cleaning solution just go around them, doesn't clean the inside. So you'll want to take your basket and lift it in and out of the wash bucket at least 20 times and allow it to drain and fill back up. That will clean out the IPA on the inside, or clean out the resin on the inside and prevent your models from cracking later on. There's too many pictures of models exploded or cracked, and a lot of misinformation about why. The reason why is because they most likely did not flush the cleaning solution inside the model, outside the model, get it nice and dry. Heat gun works well for that before they do the curing. If you do that, you'll never have issues with them cracking. Even if you don't use this to do it, I've never had one crack, and I've got some pretty big models that I've printed that are rather old, 2.5 years old, and I've never had anything crack or warp. And I've really never worried about curing the inside, but like I said, it can help, especially if you want something to be structural, to hit this on the inside of it just for a little bit. You won't get everything, it's fine. You'll do it enough. Let's see, let me chat real quick. No, I think that's it. Yep, I guess with that, thank you for watching. Enjoy your weekend. I hope you learned something, whether you're new or advanced. I hope for new users, I didn't get too much into the weeds. If you have any more questions, search me out on the Lychee Slicer Discord. I'm always there. I'm always happy to answer questions, as well as there's a few key members there who are very smart and can help you if I'm not around. With that, thank you for watching and have a good week.